In our last video lecture, we learnt about what are arithmetic progressions. Arithmetic progressions are the sequences in which each consecutive term is related to each other and the difference between two consecutive terms is a constant. We also learned how to express the general term of an arithmetic progression. We learned that the formula for arithmetic to express the nth term of an arithmetic progression is a plus n minus 1 into d, where a is the first term and d is the common difference between each consecutive terms. We also learned various types of arithmetic progression. Finite arithmetic progression, when the number of terms is finite, and infinite arithmetic progression, when the number of terms is infinite. It does not have a last term. We learned that there are three types of arithmetic progressions: increasing arithmetic progression, decreasing arithmetic progression, and constant arithmetic progression, depending on whether the constant term is a positive integer, a negative integer, or a zero. So today, based on the concepts that we have learned so far, we will try to solve some problems. I'll try to solve the first problem with you, and I invite you to solve the rest of the problems as a homework. So here we have to find the 100th term of an arithmetic progression with 2, 7, 12 and 17 as its terms. So we know that the nth term of an arithmetic progression is written as a plus n minus 1 into d. In this case, a is 2, d is the difference between two common terms, that is 7 minus 2 or 12 minus 7 or 17 minus 12, so which is 5, and n is equal to 100. So T100 will simply apply these values in the formula above, and we can write 2 plus n is 100, so 100 minus 1 is 99, 100 minus 1 into d, 5, so that is 2 plus 99 into 5, that is 2 plus 495, and the final value is 497, that is 497. So this is the 100th term of this particular arithmetic progression. Similarly, these are some other questions we can try to solve. Similarly, we'll try to solve one problem from this slide. Let us pick this question number 3. It says the fourth term of an AP is 0. Prove that the 25th term is triple its 11th term. So the fourth term, let us So the fourth term of an AP is 0. Prove that 25th term is triple its 11th term. So here let us assume that A be the first term, D be the common difference, and we shall designate each term as T. For example, T4 is equal to 0. So say for example T4 is equal to 0. This implies T4 is A plus 4 minus 1, that is n minus 1 is D. So 3D is equal to 0, right? Now prove that the 25th term is triple its 11th term. So we have to find the relation. We have to find the relation between T25 and T11. Okay, so by the general formula, Tn is equal to A n minus 1 T. So T25 will be A plus n minus 1 into D, that is 24. 25 minus 1, 24. D, n is 25. So, and similarly T11 will be A plus 10D. So now we have the relation. We have to prove that. T25 is triple S 11th term. So we have to prove that T25 is equal to 3 times T11. Okay, so so fine. So now what we will do is T25, we will say T25 minus T11. We will write the expression that will be equal to E plus, or we will say T25 divided by T11. T25 divided by T11. So A plus 24D divided by A plus 10D. Okay, so here with this equation we can say that A is equal to minus 3D. So it will be minus 3D plus 24D divided by minus 3D plus 10D. So we can see that T25 by T11 is equal to 24 minus 3, that is 21D divided by 10 minus 3D, that is 7D, which is So we will have we can say that T25 is equal to 3 into T11 and hence proved. So this was our requirement and this we have proved now. Hence proved. Moving on. So this was the problem that we had solved. Now the next very important topic of the arithmetic progression is the sum of the first n terms of an arithmetic progression. That is, sum of the terms of a series. So similarly, we assume that let A be the first term, D be the common difference, that is the difference between two consecutive terms of an arithmetic progression. Then sum of the first n terms of the arithmetic progression is written as Sn is equal to n by 2 into 2a plus n minus 1 into d. If L designates the last term of the arithmetic progression of a finite arithmetic progression, then we say that Sn is equal to n by 2 into a plus L. We will see how we derive this particular equation. However, I would recommend you to remember this formula for faster solving of problems. So here is how we derive the sum of the first n terms of a series. So if Sn is designated as T1 plus T2 plus T3 till Tn, then we can write as T1 as A, because A is the first term, T2 as A plus T, T3 as A plus 2D, and so on till A plus n minus 1 into D. Now any arithmetic progression, any equation where we do the addition, if we write the numbers in reverse order, it does not change that sum. Say for example, let me show you here. See, if you write 2 plus 3 plus 4 or 4 plus 3 plus 2, this is basically the same thing, right? So here we do the same thing. We write this equation in a reverse order. We write the terms in a reverse order and add them. So when we go to the next step, so we see that the terms comes like n into 2a plus n minus 1 into d, which brings us to the formula that sum of the first n terms of an arithmetic progression, which is also called series, like sum of the first n terms of a series is n by 2 into 2a plus n minus 1 into d. I strongly recommend you to remember this formula for solving the problems at a faster rate. Moving on, if the first sum of the first n terms of a series is known and sum of the first n minus 1 terms of a series is known, then the nth term of that particular arithmetic progression can also be written as the difference between the sum of n terms and sum of the n minus 1th term. I leave this as a task for you, dear students, that how can you derive the above equation. Please do it as a homework. Okay, so it's problem time. Let's solve some problems.